We're going to do question number 5. And I'm just looking at these steps that we just wrote. Maybe it's easier if I did it this way. Class, what's the first step? Let's ask the question. Is this one here, do we need to factor? Everyone say yes.
Yes.
I'm going to have to factor that one because I see a trinomial, A, B, and C, and then half of 2 is the invisible 1. So I'm going to use my X box to factor that. I recognize that this one below is already, I don't have to factor. Let's go ahead and factor the numerator. A times C, class? Negative 20. B value? Partner B, tell partner A 2 numbers that multiply to be negative 20, but add to be 1. Double check your numbers with your partner. Natalie, are your 2 numbers? Negative what? So to factor this, I now have x plus 5, x minus 4. And then below, you have the x plus 5. Now, this expression, x plus 5, is together. That's why I put it in a parentheses. Okay, we just did step number 1. Can I factor? Are they both in factored forms? The second question I need to do is, can I cancel anything? Class, do you see anything that's the same on both the top and the bottom?
Yes.
Okay. We're going to cancel this. But in our notes, we wrote that if you cancel it, then it's a removable whole. So I'm going to make, hopefully I'm color coding it so you can see this. This is called our removable whole. And this removable whole, x plus 5, I'm going to set it equal to 0. Class, what did I do? Set it equal to 0. And if you solve, x is equal to what? X equals negative 5. There's going to be a donut hole on our graph. All right, put your finger on what we did not cancel. We did not cancel x minus 4. Question. This is the third step. Let's see if I can get into the same picture. Is x minus 4 in the denominator? No. So I don't need to do step number 3. Step number 3 only applies in what's left over if there's anything on the bottom or the denominator of the fraction. Okay. Let's use our technology to graph for now. If you have a graphing calculator, I'm going to type in y equals here. I'm going to clear everything else out. So below your down button is a clear, and press down and then clear. If you have your Desmos, go ahead and put it in. Remember, as a tip, make sure you're using parentheses. So for mine, I have parentheses, x squared, just type in x twice, plus x minus 20, divided by x plus 5. And I'm actually going to graph both of these, the original and the pink. Class, do you think they'll be the same or the different? Someone says same. Let's type it in. I'll just type in x minus 4. So on your, if you're using Desmos, you should actually have that into 2 different functions. Now, if you graph this correctly, x minus 4 What type of function is that, class? What function family? Is it quadratic, class? No. Is it exponential? It's to the first power, so it's going to be linear. Let's see what happens. Press graph, top right. Here's the first graph in blue. Here comes the second graph in red. And that's what our graph looks like. So let's go ahead and draw ourselves a quick sketch. Really what you're graphing is a linear function. Positive slope of 1, y-intercept of -4. And what I'm going to do here is I'm arbitrarily going to draw a line at x equals -5. Now it looks like a vertical asymptote, very faintly. But this line that I'm drawing here at -5 is a restriction on the domain. Now if I draw this graph, oh, took too much space. And then kind of aiming where the donut's going to be. This is where my donut hole is where this vertical line intersects the graph. And there you have a removable hole. What does a removable hole mean? Every point on the graph is actually a closed circle, just like I did on the y-intercept here. It's a closed circle. It means it's a solution. But when you go to x equals -5, it's going to be undefined. And let me explain why. Forget the numerator, but look at the denominator. Class, if I put in -5, -5 plus 0 is? Class, -5 plus 0 is? -5 plus 5 is? 0. We just wrote down anything divided by 0 is undefined. The donut hole means that it's undefined. Here's my analogy. Pretend you're going on a roller coaster, and in real life, what's his name? Who is that guy on the Marvel who moves his hand and does magic? So Doctor Strange opens up a new portal, and you go inside the portal, but everyone else continues on the roller coaster. It's undefined of where you went, right? So this is what our graph looks like. So what are the restrictions? There's going to be a restriction at x equals -5. It's a removable hole. It is not a vertical asymptote.
Oh, this is for Heather.
Okay. Partner A, I want you to go over steps 1 and 2. And then partner B, I want you to explain the graph. Ready, set, go.
It means the denominator equals 0.
The circle means that it's undefined.
Yes.
This
X plus x minus 3.